Alright, ladies and gentlemen, let's do lesson 30, which is on graphing functions. So the first one says, graph y equals 2x plus 5 using a table of values. Use a graphing calculator to check your table and decide whether the graph represents a function and whether it's linear or nonlinear. Okay, so when we do the table, we can do this with three values, a negative, a 0, and a positive value. So let's just go with negative 2, 0, and positive 2. So we're just going to plug it into the x. So negative 2 times 2 gives me negative 4, plus 5 gives me 1. If we plug 0 in, 2 times 0 is 0, plus 5 gives me 5, and we plug in 2. 2 times 2 gives me 4, plus 5 gives me 9. So let's go ahead and graph it onto our graph over here. So we got negative 2, 1, 0, 5, 1, 2, 3, 4, 5, and 2, 9. So 5, I'm going to have to extend up here, 6, 7, 8, 9. All right. All right, there. And then we go ahead and connect. All right. So it says use a graphing calculator to check your table. So if we go into there and we have, oops, we go into our y equals and type in 2x plus 5. Then we hit second graph. Here's our table. We see at 0, we're at 5. At 2, we're at 9, like we have. If we go up, negative 2 is at 1. Okay, so then let's check to see if this graph is what our graphing calculator came up with. And those two match. Okay, so decide whether the graph represents a function. Okay, so let's do that. We use our vertical line test. So if I run this vertical line along there, I only touch one place at a time, which is true. So then this is a function. So yes, it's a function. Okay, and is it linear? Well, it makes one straight line. There's no curves in it. So yes, linear. All right, number 2, or letter B, is just the same, except for this time is x squared plus 1. So let's go ahead and use our same values, negative 2, 0, and 2. We're going to plug in for x. So remember, when you type this into your calculator, you want to put negative 2 in parentheses before squaring. So negative 2 squared gives me 4, plus 1 gives me 5. Okay, we plug in 0. 0 squared is 0, plus 1 is 1. And then we plug in positive 2 squared is 4 plus 1, so 5. All right, so let's go ahead and graph negative 2 up at 5. 0 is at 1. Positive 2 up at 5 again. Okay. All right, so let's go ahead and put this into our graphing calculator, into our y equals. I'm just going to change out this all. So we have x squared plus 1 and hit graph. And we see that it comes down to the 1, so that's good. We take a peek at our table. Negative 2 is 5, 0 is 1, and 2 is 5. All right, so that's good. If we run our line along, it only touches one place. So yes, it's a function. But now looking at it, it's linear. Well, it's not one straight line. It's got that curve. So no, it's non-linear. Oops. Non-linear. All right. C, match the equation to y equals negative 2x squared to the correct graph. Well, this one's easy. I'm just going to go to my graph calculator. I'm going to type in negative 2x squared, and I just, negative 2x squared. Yep, okay. And I hit graph. And I see it's graphing down, and it goes all the way to my origin. So it's graph 2. Nice and easy. All right, D and E, use the coordinates in the tables to match the graph with each table. Okay, so we can look at this, and D says negative 6, negative 1. So if I go over 6, I'm here, and I go down 1, that point is not on this graph. So D definitely does not go with graph 1. So if I go to 6, 4, 6, and I go, oops, this one's got a little bit different of a scale. And oh, negative 1, there we go. So, because this is a negative 2 here. So, D goes with graph 2. And we are going to assume that E goes with graph 1, but let's just double check. -3, so we go over 2, 3 is going to be here and down to 8. And we see that it crosses. So then this is graph 2. Or I mean graph 1. All right, and F. Identify the domain and range of the function. Domain, remember, is x values and range is y values. Okay, so if we take a look here at my x values, my graph starts at 0. So, and then it just keeps going, and the fact that it has an arrow, it's going to keep going on forever. So x needs to be greater than or equal to 0. Because it starts at 0, the line goes all the way at 0. So that's where the equals to comes from. All right, my y's, I see that my y starts down here. So if this looks like a -2, I'm going to say to -1. And then again, because of that arrow, it keeps going up. So y is greater than or equal to -1. G, identify the domain and range. Again, domain is x, range is y. Okay, so looking at my x's, I see that I have, it goes on in both directions. So that means it's going to go on forever this way and this way. So 2 ways I could look at this. This direction is -infinity. So -infinity. And this one is positive infinity. So I could say from -infinity, x to positive infinity. Okay? Or, because it's going to be all of those, we can call x, or your domain, is all real numbers. We do not know anything about imaginary numbers, and that's not factored into this. Okay, and the y's, my y starts here, and again, because of these arrows, it goes on indefinitely the other way. So we're going to say y is greater than or equal to +1. All right, the last one, H, the table shows the number of emails history classes sent to their senators. Make a graph and use it to find how many emails were sent from 8 classes. Write the rule in a function notation and use your calculator to check your, or use it to check your answer. Okay, remember, function notation is f of x. Okay, so if we graph this, we are going to just go up by 1s here. And I'm going to go up by, so let's go up by 30s. 30, 60, 90, 120. So 1 and 30, 2 and 60, 3 and 90, 4 and 120. Okay. Make a graph and use to find how many emails were sent from 8 classes. Oh, you know what we're going to do? Let's put these points into our graphing calculator and see how that'll help us. So to do that, remember we're going to go to Stat and Edit. Okay, we're going to put list 1 as our x's, so 1, 2, 3, and 4. And list 2 is going to be our 30, 60, 90, 120. Okay, so if I hit graph, we're not going to really be able to see these. Oh, I know. We got to do this. We need to go in and turn our stat plot on. We need to make sure that it's graphing a line. So, see how I turned it on? It's in line. We have list 1 for x's and list 2 for y's. I'm also going to change my window because I go from 1 to 4 in my x's. So my x's, I'm just going to say -5 to, and we said we need to go at least 8, so let's go to 10. We can go up by 1, so that's fine. Our y's, we are going to know we go at least 120. So let's overestimate because we're going to need to check out for 8 classes. So let's just go to 200. So we can leave it at -10. Go to 200, and let's make a y scale of 10. I want to go in and clear out my function from before, and now we can hit graph. Okay, so there's our points. It still doesn't show us extending it out to the 8. So we can go into, let's see here. Which one do I want to go into? All right, okay, so let me take you, we're going to go into stat, arrow over to calc. Because we see our graph was a straight line, we can do number 4. Number 4 is linear regression. This is going to write a function for us for our data. List 1 is our x's, list 2 is our y's, and calculate. So this tells us that a is 30, so our slope is 30 and our y-intercept is 0. So that's my function notation, 30x. So I'm going to go in now into my y equals and type that in, 30x, and graph it. So there's my original points, and now my graph is coming through there. Okay, I'm going to hit trace, and I'm going to follow along, and until that didn't work for what I wanted. Okay, that's fine. We have our function, so we can plug 8 in here for x. So 30 times 8 is going to tell us how many letters that 8 classes wrote. And that turns into 240 emails. All right, there you are, ladies and gentlemen.